station on Space to Ground.
Another launch from Baikonur. Welcome to Space to Ground. I'm Dan Hewitt. There was a summertime delivery to the space station this week.
And liftoff.
The Russian Progress 67 cargo craft launched on a sunny day from Kazakhstan on Wednesday. Riding atop a Soyuz rocket, the ship made the flight into space and onto the orbiting laboratory. After 2 days, Progress docked to the back end of the Zvezda service module early Friday morning, delivering more than 3 tons of food, fuel, and supplies for Expedition 52. A newly installed experiment is going to be looking at some of the most extreme stars in the galaxy. The Neutron Star Interior Composition Explorer, or NICER, was pulled out of the trunk of the Dragon cargo craft and installed on the station this week by robotics controllers on the ground. It will train its instruments on neutron stars, remnants of massive stars that, after using up all of their fuel, have collapsed into insanely dense spheres about the size of New York City. There is so much stuff packed into these stars that just 1 teaspoonful of matter from them would weigh 1 billion tons on Earth. Some of these neutron stars appear to pulse as they emit huge beams of electromagnetic radiation while spinning, which is why we call them pulsars. Scientists are going to use NICER to test using pulsars as a sort of galactic GPS. The first time we'll demonstrate if we can use these extreme beacons for future navigation of the deepest parts of space. This week's Twitter question comes from GB, who wanted to know how much radiation an astronaut gets on station or a mission to the moon. Well, it's not an exact figure since there are so many variables, but we do our best to make it as small as possible. Astronauts on the station do receive higher doses of radiation than us on Earth, but are protected from the most harmful stuff since they're well within Earth's magnetic sphere. Solar events in areas like the South Atlantic anomaly can increase their exposure, which is carefully tracked by a number of radiation monitors throughout the station and carried by the astronauts themselves. Missions to the Moon and Mars carry bigger radiation concerns as they cross into open space where galactic cosmic rays can strike, or will be on surfaces that don't have the protection of a strong magnetic field like Earth. That's where new shielding and other countermeasures will be extra important. Keep sending your questions using the hashtag #SpacetoGround. We'll see you next week.